The universe might not be everything. That sounds impossible. For decades, science has treated the universe as the ultimate stage. Everything that exists, every galaxy, every star, every atom, all contained within one vast cosmic structure. But now, something strange is forcing scientists to question that idea. There are signals, patterns, small irregularities hidden deep in the oldest light in existence, and they should not be there. These discoveries are subtle, easy to miss, but once you see what they suggest, the conclusion becomes unsettling. The universe we know may only be a tiny part of something far bigger, something we cannot fully see, something that may exist beyond what we once believed was everything. In this video, you will learn what scientists mean by the edge of the universe, why that edge might not be real, and what new evidence is making researchers consider the possibility that there is something beyond it. By the end, you will understand why this question is one of the most important and disturbing mysteries in modern science. To begin, it is important to understand a simple but often misunderstood fact. When scientists talk about the universe, they are not always talking about all of existence. Most of the time, they're talking about something more limited, something called the observable universe. The observable universe is not the whole universe. It is only the part we can see. This limitation comes from one fundamental rule of nature: light takes time to travel. Nothing moves faster than light, not information, not matter. Nothing because of this. Every time you look into space, you are also looking back in time. The light from distant galaxies has been traveling for millions or even billions of years before it reaches Earth. Some of the light we detect today began its journey long before the Earth even formed. Now, here is where things become strange. The universe itself is about 13.8 billion years old. That means, in theory, the farthest light we could see should come from objects 13.8 billion light years away. But that is not what we observe. The observable universe is actually much larger than that. It stretches about 93 billion light years across. This seems impossible at first. How can we see something that far if the universe has not existed long enough for light to travel that distance? The answer lies in something even more surprising. Space itself is expanding. Since the very beginning, the fabric of the universe has been stretching. Galaxies are not simply moving through space. Space itself is growing between them. As a result, light that started its journey billions of years ago has been traveling through a universe that is constantly expanding. This means the objects that emitted that light are now much farther away than where they were when the light first began traveling. So the observable universe is not defined by distance alone. It is defined by how far light has been able to reach us since the beginning of time. And beyond that limit, there is darkness. Not because nothing exists there, but because its light has not had enough time to reach us. This creates a kind of cosmic horizon, a boundary around everything we can observe, a limit to what we can know. But here is the key detail that changes everything. That boundary is not a physical edge. There is no wall, no barrier, no sudden end to space. It is simply a limit based on time and light. Beyond it, the universe could continue, it could stretch infinitely, or it could connect to something even more complex. We do not know, and until recently, science had no way to even begin answering that question. For a long time, this limitation was accepted. Scientists focused on what could be measured, what could be observed. The rest was considered unreachable, but new data has started to challenge that comfort. By studying the oldest light in the universe, known as the cosmic microwave background, scientists have found patterns that do not fully match predictions. These patterns are extremely faint. They exist at the edge of detectability, but they are consistent enough to raise serious questions. Some regions appear colder than they should be. Others show alignments that should not exist if the universe is uniform in all directions. These are not simple errors. They have been studied, rechecked, and debated for years. And one possible explanation is deeply unsettling. Some scientists believe these anomalies could be signs of interactions with something outside our observable universe, not distant galaxies, not hidden matter, something beyond the horizon itself. This idea sounds extreme, but it is grounded in real physics. In some models of the early universe, space did not expand just once. It expanded many times, creating separate regions, sometimes called bubble universes. Each of these bubbles could be its own universe with its own properties, its own structure, and possibly even its own laws of physics. If that is true, then our universe is not alone. It is one of many, and if these bubbles ever came into contact, even briefly, they could leave marks, subtle traces. Small distortions in the fabric of our universe, exactly the kind of distortion scientists are now observing. This does not mean the answer is confirmed, far from it. The data is still being studied, alternative explanations still exist, but the possibility alone is enough to change how we think about reality, because it means the biggest assumption we make, that the universe is everything, may be wrong. There could be more, much more, and we may already be seeing the first hints of it. This is where the mystery begins. Welcome to the channel. If you are interested in the deepest questions about space, reality, and the unknown, make sure to subscribe. The edge of the universe sounds like a place, a distant boundary where everything simply stops. A final line where space ends and nothing exists beyond it. That idea feels natural. Every object around us has an edge. Every space has a limit, but the universe does not follow that rule. There is no wall at the end of space, no barrier, no cliff. No sudden drop into nothingness. The edge of the universe is not a physical place you could travel to. It is something far stranger. It is a limit created by light. Everything you see in the night sky, every star, every galaxy exists inside a bubble of visibility. This bubble is centered on us, not because we are special, but because light needs time to travel. And there is only a finite amount of time since the universe began. Light from very distant regions is still on its way. It has not reached us yet. Some of it never will. This creates a horizon, a boundary that separates what we can see from what we cannot. Scientists call this the observable universe. But here's the part most people do not realize. This horizon is not fixed. It is constantly changing. As time passes, more light reaches us, the observable universe grows, more galaxies slowly come into view, more of the past becomes visible. At the same time, something else is happening. Space itself is expanding. This expansion is not like an explosion moving outward from a center. It is happening everywhere at once. Every point in space is stretching away from every other. Our point. Because of this, distant galaxies are being carried away from us. The farther they are, the faster they move away. At extreme distances, this speed becomes greater than the speed of light. Not because objects are breaking the laws of physics, but because space itself is expanding between us and them. This leads to a strange and unsettling consequence. There are galaxies in the universe that we will never see, not now, not ever. Their light will never reach Earth. Even if we wait forever, even if technology becomes infinitely advanced, those regions are permanently cut off from us. They exist, but they are unreachable. This means the universe is divided into two parts. The part we can observe and the part we can never access, and the line between them is not a physical edge. It is a horizon based on time, distance, and the speed of light. In a way, we are trapped inside this horizon. Everything we know about the universe comes from within this boundary. Every theory, every observation, every piece of data is limited by it. Beyond it, there could be more galaxies, more structures. There's something completely different, but we cannot see it. We cannot test it directly. We cannot cross that boundary. And that raises a deeper question. If this edge is only a limit of what we can observe, then what lies beyond it is not empty. It is simply hidden. Long before stars and galaxies filled the sky, the universe was a hot, dense glow. As it expanded and cooled, that glow faded into a faint radiation that still surrounds us today. It is called the cosmic microwave background. It is the oldest light we can detect, a snapshot of the universe when it was only about 380,000 years old. For decades, scientists have studied this ancient signal in extreme detail. It is almost perfectly uniform. The temperature varies by only tiny fractions of a degree. That smoothness was expected. It supports the idea that the early universe expanded rapidly in a brief moment known as inflation. But hidden inside that smooth glow are small irregularities, tiny fluctuations. These variations are important. They are the seeds that later formed galaxies and clusters. Without them, nothing we see today would exist. At first, everything seemed to fit. The patterns matched predictions. The models worked. Then, better data arrived. Space missions with higher precision began mapping the cosmic microwave background with incredible accuracy. Every small variation was measured, every detail was recorded. And that is when the strange patterns started to stand out. One of the most famous is known as the cold spot. It is a region of space that is significantly colder than the surrounding areas. Not by much, but enough to matter. It is far larger than expected, too large to easily explain with standard physics. Scientists tried to understand it. Some suggested it could be caused by a massive empty region of space known as a supervoid lying between us and that part of the background radiation. But deeper observations did not fully support that idea. The cold spot remained. Then there were alignments, patterns that appeared to stretch across vast regions of the sky. These alignments seemed too organized, too structured, almost as if there was a preferred direction in the universe. That should not happen. The universe on large scales is supposed to be the same in every direction. This principle is one of the foundations of modern cosmology. But these observations hinted at something different. Even more puzzling, some fluctuations appeared stronger than expected, while others were weaker. The distribution did not perfectly match the predictions of the standard model. Each anomaly on its own could be dismissed as coincidence or noise, but together they formed a pattern, and that was difficult to ignore. Statistically, some of these features should be extremely unlikely, not impossible, but rare enough to raise serious questions, and this is where the idea becomes unsettling. If these patterns cannot be explained by known physics, then something else must be influencing them, something beyond the models, and something beyond the models. Some researchers began to consider a possibility that once belonged only to speculation, the idea that our universe might have interacted with something outside itself. If another region of space, another universe existed beyond our observable horizon, and if it came into contact with ours in the early moments after the Big Bang, it could leave behind traces. Not obvious marks, not clear signals, but subtle distortions in the background radiation. Exactly the kind of distortions now being observed. These are not direct detections, they are clues, small hints buried in ancient light. But they point toward a possibility that changes everything. The idea sounds extreme at first. More than one universe, entire realities existing beyond our own. For a long time, this was treated as speculation, a concept for philosophy, not science. That began to change when scientists tried to understand the earliest moments after the Big Bang. During that time, something unusual may have happened. A brief phase of extremely rapid expansion known as cosmic inflation. In a fraction of a second, space expanded faster than the speed of light. This expansion smoothed out the universe and set the stage for everything that followed. But some versions of this theory lead to a surprising outcome. Inflation may not have happened just once. Instead, it could be happening continuously in different regions of space. In this picture, space keeps expanding but not evenly. Certain areas stop inflating and form stable regions. Each of these regions becomes its own universe, a bubble. Inside each bubble, conditions can be different. The laws of physics could vary. The strength of forces could change. Even the basic structure of matter might not be the same. Our universe would be one of these bubbles. This idea is called the multiverse. And it is not based on fantasy. It comes directly from equations used in modern physics. If this picture is correct, then these bubble universes might not be completely isolated. In the earliest moments when they were still forming, they could collide. When two of these bubbles meet, the collision would release enormous energy. It would disturb the structure of space. It would leave behind a mark, not a visible explosion, not something that looks dramatic in the sky today, but a subtle imprint in the fabric of the universe. That imprint could survive for billions of years, and it could still be visible in the cosmic microwave background. Scientists have searched for these signatures, circular patterns, unusual temperature variations, regions that stand out from the expected randomness. Some of the anomalies match what these collisions might produce. The cold spot is one example. Its size and shape have led some researchers to suggest it could be the result of a collision with another universe. Not all scientists agree. Many remain cautious, but the idea is taken seriously enough to be studied in detail. There are also hints of circular rings and patterns in the background radiation that do not fit cleanly into standard models. These features are subtle, they sit at the edge of detection, but they continue to appear in different analyses. Another lesser-known detail adds to the mystery. Some theories predict that if a collision occurred, it would create a preferred direction in space, a kind of asymmetry. This connects with the strange alignments that have already been observed. It is not proof. B, UDIT is consistent. The possibility grows stronger with each piece of unexplained data. If even one of these signals is truly the result of a collision with another universe, then the implications are enormous. It would mean our universe is not alone. It would mean our universe is not. It would mean that beyond our cosmic horizon, there are other regions of reality, each with its own story. And it would mean that the edge we see is not the end of existence, but the boundary of a much larger structure that we are only beginning to detect. Modern physics is powerful. It can predict the motion of galaxies. It can describe the life cycle of stars. It can explain how the universe expanded from an extremely hot and dense state, but it has limits. At the largest scales and the earliest moments of time, the rules begin to break down. One of the most important theories in physics is general relativity. It explains how gravity works. It describes how massive objects bend space and time. It has passed every major test for more than a century, but when it is pushed to extremes, it starts to fail. At the very beginning of the universe, conditions were extreme beyond anything we can recreate.
Density was enormous. Temperature was unimaginable. In that state, general relativity predicts something known as a singularity, a point where density becomes infinite, a place where the equations stop working. This is not just a technical problem.
It means the theory cannot describe what actually happened at that moment. The starting point of the universe is still unknown. Another major framework, quantum mechanics, describes the smallest scales of reality. It explains particles, forces, and interactions with incredible precision, but it does not fit smoothly with general relativity. The two theories work well in their own domains, but when combined under extreme conditions, they clash. This creates a gap in our understanding. And that gap becomes critical when trying to study the universe as a whole. The Big Bang model explains much of what we observe: the expansion of space, the cosmic microwave background, the distribution of galaxies, but it does not explain everything. Some of the anomalies in the background radiation do not fully match its predictions. Certain patterns appear stronger or weaker than expected. Some alignments seem too organized. These details may be small, but they matter. Even the rate of expansion of the universe has become a problem. Different methods of measurement give different results. Observations of distant supernovae suggest one value. Measurements based on early universe data suggest another. The difference is small but persistent. This tension has not been resolved. It suggests that something may be missing from our models. Dark matter and dark energy add to the mystery. Together, they make up most of the universe, yet they have never been directly detected. Their existence is inferred from their effects. That means most of reality is still unknown, and when it comes to what lies beyond the observable universe, the situation becomes even more uncertain. We cannot see beyond the cosmic horizon. We cannot send signals there. We cannot test it directly. All conclusions must come from indirect evidence, from patterns, from anomalies, from hints in the data. This makes the problem difficult. It also makes it dangerous. Small errors can lead to big conclusions, but ignoring the data is not an option because the data is pointing towards something deeper. The current theories were built to explain what we can observe, but if there are influences from beyond that boundary, those theories may be incomplete. They may describe part of reality, but not all of it. And if that is true, then the universe we understand is only a fraction of what actually exists. Which means the biggest discoveries may not come from what we can see, but from what we cannot explain. If these ideas are correct, then the universe is not the full picture. It is only a part of something larger that changes the meaning of space itself. For a long time, infinity was used to describe the universe: endless space, no boundaries, no outside. Everything contained within one structure that stretches forever. But if our universe is just one region, one bubble, then space may not be infinite in the way we thought. It could be finite in some sense, not because it has an edge you can reach, but because it is one piece of a much larger system. Beyond it, there may be more regions, more universes, each separated by distances that cannot be crossed. each with its own history. This leads to a deeper idea. The laws of physics may not be universal. Inside our universe, the rules seem consistent. Gravity behaves the same way. Light travels at a fixed speed. Particles follow predictable patterns. But these laws may only apply within our cosmic bubble. Outside, things could be very different. The strength of gravity could change. The structure of atoms might not exist in the same form. Time itself could behave in unfamiliar ways. Even small changes in these constants would create a completely different reality. Stars might never form. Matter might remain unstable. Or entirely new types of structures could exist that we cannot even describe. This is not just speculation. Some theories suggest that the constants of nature are not fixed by necessity, but selected by conditions. If that is true, then different universes could have different settings. Our universe would be one version among many possibilities, and it just happens to support galaxies, stars, planets, and life. This introduces a strange idea. The reason the universe looks the way it does may not be because it had to be this way, but because this is one of the rare conditions where observers can exist. That shifts the perspective entirely. The universe stops being the ultimate system. It becomes one example within a larger structure, and that structure may not have a simple explanation. It may not have a clear beginning. It may not have a single origin point. Instead of one big bang, there could be many, each creating its own universe, each unfolding independently. Some may expand forever, others might collapse, some may never form complex matter at all, and we exist inside one of them. This raises questions that go beyond physics. Why does this larger structure exist at all? Why are there multiple universes instead of one? Why do the laws in our region allow complexity and life? These questions do not have clear answers, but they point to something important. The idea of everything may be far bigger than the universe we observe, and if that is true, then what we call reality is only a small part of a much deeper and more complex system that we are only beginning to understand. The edge of our universe is not the end, it is a limit to our view. And beyond that limit, the true scale of existence may be far greater than anything we have ever considered. The edge of the universe is not a wall, it is not a boundary where everything ends, it is a limit created by light, time, and our position in space. What we see is only a fraction of what exists. Beyond that horizon, there may be more galaxies, or something far more complex, entire regions of reality that we cannot directly observe, not because they are empty, but because their light has not reached us and may never reach us. And now small cracks are starting to appear in what we thought was a complete picture. Strange patterns in ancient light, signals that do not fully match our models. Possibilities that point beyond our cosmic horizon. These are not final answers, but they are clues. For the first time, science is not just asking what exists inside the universe. It is starting to ask whether the universe itself is only one part of something greater. Questions like this were once considered impossible to explore. Now they are being studied with real data, real equations, and real observations. That changes everything, because it means the biggest discovery in human history may not be finding something new within the universe. It may be realizing that the universe was never the full story. And the most important question still remains. Are we looking at the edge of everything, or just the beginning of something much larger? If this idea changed the way you think about reality, take a moment to like the video and subscribe to the channel. There is much more to explore, and the next discovery may be even more surprising.